Okay, good afternoon. My name is Shendong Zhao. I'm an associate professor in the National University of Singapore in the Computer Science Department. It's my great pleasure to introduce my vision of the future, how we interact with computers, and also my vision of metaverse to you. It's called heads-up computing. So why do we need a new interaction paradigm? To answer that question, let's look at the big picture, the important question of how human has been evolving with our tools in the past. And this figure, you probably see it online sometimes. It's actually a very profound and thought-provoking summarization of how human has been evolving with our tools. And as you can see from the figure, we have been going upwards in our early days, but in the recent couple thousand years, the trend is actually going downwards. Even though those tools has enabled a lot of advances in our society, but it actually brings down certain aspects of lives that's less desirable. So with that kind of background, we wanted to reverse that again and hopefully make us liberated and live a better life in the future. So what exactly has been going down? Well, one thing I think, if I want to ask you, how do you guys feel about work-life balance in the recent days or compared to what our ancestors? If you look at the different ages in history, the hunter-gatherer stage, the farming stage, the Industrial Revolution, and now most of us work as knowledge workers, right? I mean, if you really think about it, do we actually have a better work and life balance compared to our ancestors? Actually, the answer is probably not, right? Not the case. But what is the issue here, right? Why we actually drive into this situation? Well, the answer is actually quite profound because there exists a very interesting trade-off between these as we advance in our technology. As a society, right, the technology advancement allowed the society to become more and more complex and more powerful. So that's why the civilization, the nations adopt advanced technologies, able to overtake those less advanced technologies. And that's why we have to go into this way of living. But if you look at the individual lives, right, if you compare with our ancestors in the hunter-gatherer stage especially, we are much more specialized. Right? We actually no longer use a lot of the capabilities the nature has given us over millions of years. And our life, in many ways, if you are talking about working life, is actually very constrained. Right? Many of us just sitting in our office 8 hours a day, facing a computer, and then we call that working, which is very unfortunate. So how can we reverse this potentially in the future, right? To go back from our old good days where we have freedom and less constraint, to have that kind of things in the future. So let's looking at this fundamental question again, right? We invent tools and technologies to help us to conquer nature. But at the same time, those tools and technology actually go back and shape our lives, right? So that's why you can see these up and downs curves. The tools and technology we invented can come back and bite on us and make our life less desirable. And if we want to have a better life and we want to invent new tools, and my vision and what I hope that we can do as a knowledge worker in the future is that those knowledge workers no longer just done inside of your office. It can be done anywhere in nature, and it's in harmony with many of our other activities. You can spend more time with your family. You can spend more time play and chat and socialize with your friends. At the same time, you are just as productive, as effective, or even more productive and effective as what you are doing right now. With that, let's try to analyze the problem of existing tools and see how can we improve on that. So what are some of the problems of the existing tools? First, many of the tools that we have today is designed in what we call a device-centered manner, right? If you look at your mobile phone, if you look at your laptop, right, you can see that the device is always in the center. If you think about it, because the device, all its input and output capabilities is centralized at one point. And that's why we have to adjust our body posture, right? We have to look down, we have to put our hands on it to interact with it. And as a result, we adapt our posture to work with those devices. Okay, and the second problem of the existing tools is that we have our daily lives, we have our things we want to do, but we also have the computing tasks we want to work on. And both of these tasks actually require the similar set of resources on us. And that's why it causes a conflict. So we can either do our daily task or do our computing task, but not together or not in a harmonious way. And the third issue of existing tools is that they require so much attention from us. Right? So whenever you try to interact with computers, devices, whether it's a mobile phone, whether it's a laptop, you just isolate yourself from the surrounding, from social environment, and become less and less, it works not so well with the environment. Okay, so what does heads-up computing is really about? Well, the vision of heads-up computing is to offer a more seamless, just-in-time, and intelligent computing support for our daily lives so that we can do a lot of works everywhere, anywhere, anytime. And the approach of this heads-up computing involves three major aspects. One is instead of putting all the input and output in a centralized device, we choose a distributed hardware designed to match our humans' input and output capabilities. And then we had to change the way we interact with computers. Instead of today mostly typing, right, we wanted to use more multimodal. Right? Imagine how we interact with other human beings. We speak, we use gestures. If we try to adopt these kind of interaction methods, we will be able to do things more naturally. And third, we want to make the computer aware of our resources so that the interaction you have to do with computers can be done in a more harmonious ways. And to do that, we introduce what we call a resource-aware interaction model. Okay, let me just play a video.
The vision is on what we call the heads-up computing. It's an interaction paradigm that focuses on living instead of interacting with devices. And it adopts what we call a human-centric design. So the device fits the human's needs, human's design. Instead of the traditional approach where you put input and output all in one piece of device, and humans have to change their posture and change their way of interaction to cater to the device.
I will go to the meeting at 2 p.m. Find me the nearest convenience store that is open now.
With this new heads-up computing design, human now can engage in a variety of activities and still receive seamless help from devices. A lot of our natural activities that we want to engage in, such as running, cooking, socializing with friends, also requires our visual and manual movement. This causes a conflict. But with heads-up computing, we try to utilize voice, subtle gestures as a means to interact. And with the distributed design, we can allow people to actually interact with computers, receiving information without disrupting their current activities. And we call this the synergistic interaction. Existing interaction paradigms mostly are reactive in nature. What it means is that they only respond to humans' requests. But we want the future interaction paradigm to be more proactive so that it can anticipate the human's needs and provide just-in-time help without too much human's involvement. This naturally facilitates a balanced, healthy living.
We wanted to change the interaction paradigms in a sense to utilize more of our body and to maximize the human potential. This can be done through the replacing the traditional hand interaction and with the gesture interaction.
Okay, so that's a quick video about what is possible in the future. And our lab is actually actively working on this vision, and we have already developed quite a few different applications that allow you to do various things in this heads-up manner. So let me just try to introduce this approach a little bit more in details. First is, instead of device-centered design, we want to use what we call human-centered design. So what does human-centered design involves, right? Instead of having one piece of device where all the input and output is centralized at, we can use what we call wearable computing, where in this case, you can see that you can wear smart glasses, which is next to your eyes for you to receive the visual feedback, and then you have earphones for you to hear what the virtual assistant want to tell you about. And then you may have a hand controller which you wear on your ring finger to interact and navigating the information space. So the device is actually distributed to our input and output component of our body. And we imagine that we will probably have two pieces that compatible and can be used for the wearable computing. One is what we call the headpiece, and the other one is the handpiece. And then can potentially be a body piece, which can be a robot, right? But the handpiece and headpiece goes with you on your body. And the reason for that is if you look at our human's sensor and actuator, you can see that our hand and the heads are the two most important hotspots in our body, right? The head has all these input and output sensors right there. It's so rich so that we wanted to be able to put something there to get really close and compatible with that input and output capabilities. And our hands is our way to change the world, right? It's the manual part. So we also want maybe a device to be able to sense the hand movement and interact with the hand right there. So that's why we need a handpiece and a headpiece. Okay, So the next approach is we call the multimodal interactions. So instead of right now we're heavily relying on keyboard and mouse or the touch sensors, right? We wanted to utilize more voice, eye tracking, subtle gestures, and then we want to use optical head-mounted displays. Okay, so why is that? If we look at the daily activities we are doing, right? These are the kind of the list of things that most people will do on an everyday basis. You find out that most of these activities, they also requires your visual attention and also your hands, right? So if you design computing interaction techniques also requires your visual heavily and your hands, then you will have a conflict, right? So daily activity is eyes and hands busy. If your human-computer interaction is also eyes and hands busy, you have a conflict. So we wanted to looking for means in which it's less conflicting with these type of activities. So we utilize, the transparent glasses so that you can see the environment as well as the digital information at the same time. Use more audio, use speech, and you can use subtle gestures which can be performed together with other type of daily activities. And lastly, we want to look into what we call a resource-aware interaction model. So what does that really mean, right? So when we actually, in our world, right, humans have all the resources we have. We have our vision, hearing, cognitive resources, and our daily activities will have to take some part, right? If we are doing, for example, walking, we have to take some of the visual and manual capabilities away, right? So in this case, we also have our environment. We have impose some additional constraints on that activity. So if the computer is smart enough, it will try to utilize what's remaining as our resources and try to design the interaction can be easily performed, use that remaining resources. Of course, this doesn't fit every scenario, right? But if we can make more of our activities designed in this intelligent, efficient manner, then our life will be much more harmonious with nature. Of course, doing this is a big project. It's a big vision, right? And it requires a lot of different technology to make it happen. So AI, big data is some part that you want to augment the brain, and you want to use sensor robotics to augment your input and output. You want human-computer interactions to connect the human and the technology. And then eventually you want to scale it up through social computing. Okay, so this is the vision that we presented to you. Of course, it's just starting. And I just wanted to say that we as human design technologies, invent technologies. Technology, whatever we design, can actually go back and affect our lives. So some of these effects are long-term, and you may not notice. But it's very important for us to think how technology can affect our lives so that we can design better technologies to create a better future. And people have been talking about metaverse. People have been talking about new technologies. But I think it's very important to think about how should we design it so that we will actually live a better life in the future instead of a more miserable life. With that, I will be happy to take any questions. Thank you. It's the last talk, so dinner is on the way, I guess.
Hello. I'm wondering, I'm not a tech person, whether the only change is the interaction with the machine, because if you could, like all the science movie, they project the screen of the mobile or the computer in an imaginary screen and touch. So what you're doing, is it like this logic of we can touch, or is it like more sophisticated in terms of interaction, or like changing the logic?
Okay, that's a very good question. I think the question is, in the movie, there's many kind of visualization of what the future technology will like, such as Minority Report, right? Such as the Iron Man, all these things. They propose things that's very interesting to look at, but if you look at these technologies and the way they interact from maybe a more professional or a long-term perspective, many of these technologies they present actually is not workable. If you do that for a long time, your hand is really tired, and it actually still doesn't allow you to, at the same time, doing many other things. It's very cool to look at, but they do have some elements of what we want, right? So in order to come up with technology that can be harmonious with our lives, we have to design it very carefully. That's why we think about how the interaction actually compatible with the current activity right now. For example, if I'm walking, right, what does the presentation of information should be? Maybe it can only present at a rate of maybe 5 words per second to me. But if there's more crowded people, you have to reduce the information amount to much smaller so that I can still be able to navigate through a crowd, yet receiving that information. And then if I'm in an even more dangerous situation, it should stop, right? And then maybe it will change the information from visual to audio to me. So there's actually a lot of very careful thoughts you need to put into to make that into what we can really use in the real life. Yeah, so that's something we are working on. Yeah, thank you for the excellent question.
Thank you, Professor. My name is Gary, and I'm from Skylab. I have a question with regards to the machine learning part, because everybody gestures differently, and at the same time, it seems like in order for us to have a very natural posture, the sensor devices, while collecting the environmental data, will need a edge computing to be on mobility. As you walk, the base station will be handing over and orchestrating the workload as you move. So in terms of network latency, edge computing, and workload movement orchestrations, there are still a lot of problems to be solved. I'm very inspired by what you and your team is trying to do. I'd just like to check with you if you have explored some of all these other sets of challenges from ML side, workload migration, cloud orchestration, edge computing, as well as the machine learning part. Thank you very much.
Thank you. That's a very good question. First of all, I want to say that, so the question is, how does the machine learning play a part? And have we explored anything in the machine learning aspects to incorporate this vision and try to realize that in the future? So the answer is that, yes, machine learning is going to be a big part of it. As one part of part of the thing that I mentioned in the video is that we want to change the interaction from more reactive, which is what we currently have, to proactive. This means that the computer would have a better understanding of ourselves, right? To understand maybe our attention, understand our cognition, understand our emotion, and then it try to present the right interaction to us. So this requires quite a bit of, like what you said, the edge computing and be able to computing the data based on small samples, and probably build a profile of you, and it can keep updating with the daily samples that it has. So one of the works that one of my colleagues is working on, they're building smart glasses which has eye tracker, and then they can kind of look at your eyes like every couple milliseconds. Then it will know where you're looking at, what's your attention like. And then one thing about our eyes is that our eyes, most of the time just wandering around. But when we see something interesting, we will transition from what we call the random saccade to a smooth pursuit to follow up that target, right? That happens maybe only a small proportion of our daily lives. So instead of trying to compute things continuously, which takes a lot of bandwidth and computing resources and battery, right? If we know what humans actually interested in based on observing our eye pattern. So you're changing from a random saccade to a smooth pursuit. Okay, that's when you're interested in something. And then I turn on the camera to look at that. And then I do some calculation about it. And then I will try to update, and I can build causations. I can look at your emotion. Oh, this scene you look at actually make you happy. This scene you look at actually make you sad. And I can build some reasoning behind it. Then I will be much better to interact with you. So the ultimate vision is that this wearable device will become a personal assistant, intelligent personal assistant that understands you very well. So that imagine that you have a very, very good personal assistant who has been working with you for years. You just have to give him or her a look, and he or she will knows what you want next, and then prepare things for you, right? So that's the ultimate vision that we are looking for, and that requires machine learning. Yeah. Yes. Okay.
Hi.
Okay, great. I can repeat that question. So the question is, do I see the potential of brain-computer interfaces? The honest answer is no. Brain-computer interfaces is very interesting and probably very fascinating, but we know that if you cannot like drill a hole into your brain, into your head, and then try to get the signal more accurately, even that the signal you get is not so accurate because a lot of things are happening in the neuron inside of your brain, but you can only access that information from the outside. Right? Imagine that you want to access the information that also covers by your skull and your hair, and then you try to get that information. The result is it's very, very noisy. So that noisy data, you can only use it for complementary purposes. If you want to use it for more serious interactions, you know, if my colleagues who work on brain-computer interfaces, they said this is your last resort. If anything on your body is still moving, use that. If your eye can blink, use eye blinking is way accurate than using your brain, right? If your eye cannot even blink, nothing can move, then go to brain-computer interface. Yeah. But it can be a complementary channel. It can be a complementary channel. So it can, if you have other channel available, you complement that with your brain, with the other channel, then it can add additional benefits. But standalone is very challenging. Okay, I think I'm over time. Yeah. Thank you so much for the excellent questions. Hope to see you next time.